Kia ora. Good evening. Welcome to one more session of Coding Night. Welcome, you guys. Just coming like to the session. So we're talking here like 8 p.m. New Zealand daylight time. And tonight you're gonna learn a bit more. Well, if you don't know, you're gonna learn about solid design principles. But if you know, I guess you're gonna learn a bit more about that. And we're gonna have examples in C sharp, right? Didactic examples. So you if you're like a more junior dev, you're gonna learn like the concepts. And I'm also sharing some examples so on GitHub, and along like this session I make like those links available. And if you're more like senior, more like lead developer as well, I guess you're gonna learn like the or consolidate some knowledge that you have. And tonight it's going to be me, so we don't have like a guest speaker. And I'm just sharing my screen here. Let me just go to the next slide. Yeah, a little bit like about me. So if you know me or if you don't, so my name is Marcel Medina. I'm a software developer and Azure specialist. So I focus on Microsoft technologies. Also like a playground enthusiast and coder. If you don't know, like I also co-founder of playgokids.com, a mobile app that contains playgrounds around the world. Currently, I'm working as a lead developer at my fullback, and my blog is tech.playgokids.com. I also would like to say something about like the Code Night user group. That's where like I invite developers to join, and also like to learning go like along this journey, because we have different sessions and we always come with like some good content. And well, as a summary, so we are a community of developers and where we love coding and we follow the best practices, and we focus more mainly on Microsoft technologies. But the intent of this group, as I said, like from juniors to lead devs, to enable developers with practical knowledge, right? So you can launch your career. We're also part of the azuretar.com uh, group. So basically, it's a cloud native group where we explore the latest and coolest trends in the cloud native space. Also, a part of the .NET Foundation.org. So, mo- in the at the beginning, we have like many sessions where we talk about like the projects of .NET Foundation, and I invite you to have a look at the YouTube channel to see like those links. Well, we're going to talk about a little bit about the agenda, but before we get to that, I'm going to just say like that just the approach for this session, so you are aligned and understand what are going to be presented. But basically, we're going to quickly talk. This is a demo session, basically. But you're going to learn about the principles and understand where to apply them. And if you're like a junior dev, so in general, when you're doing like interviews, you're gonna get like in a hiring process, you're gonna face with questions around solids, right? So I invite you to grasp those principles and also examples, because uh, you can basically tell about the principles, but if someone asks you about some examples, I'm sharing those links, and basically they are generic, I would say, examples that you can use and talk about it. For the more lead devs, I invite you to, well, we probably should know like those principles, but sometimes if you, well, I would say a hiring process, but if you want to do some sort of demos or explain details, I invite you to memorize those examples, right? So as I mentioned, they are didactic and they're good uh, to explain and talk about it. Well, with no further ado, I'm just gonna start, and we're gonna go like straight to it, right? So we have like 1 hour session tonight. So solids, right? What it is? What is it? I like this definition. That's one of the most popular design principles for object-oriented software development that became really popular, like I'd say the past, well, I'd say in the market, past 10 years. I think like before that, even like with the, I can say that Robert Martin, right? So he introduced like a paper in 2000s around like design principles and design patterns, but the solids acronym was only created by Michael Feathers in 2004. But even like from 2004 2010, that wasn't that uh, popular. I think after that, that's when developers start like adopting and understanding in details. It got like really popular. I'm just sharing here like some links so you can view this when you have like a moment. But I'm gonna go now through the principles. Um, just starting, right? So we have like how many principles? Well, I just put like one in here. So according to the acronym, right? So we have 5 principles. The S is single responsibility. We also have like a SRP, which is the single responsibility principle. So in depending on the literature that you are checking, you also can see like those acronyms for the single responsibility. We have the open close principle, OCP, the Liskov substitution principle, LSP, interface segregation, ISP, and dependency inversion, right, DIP. Uh, I think like as within this context, right, we're talking about the principles, but what what you're gonna notice is that, well, I think the main drivers, if we were to summarize, is about cohesion and dependency. You're gonna see that these principles fit really well onto those main, let's say, definitions. Cohesion, because you're gonna see that if things belong together, they make sense to stay together. And at the same time, like with the uh, around the dependencies, right? So we want to do like the decoupling, and that's what like it's one of the parts you're gonna clearly notice that solid brings. And as a developer, you need to know like those principles. Some of these principles you can apply on daily basis, others are not necessarily, and I'm gonna mention when we get to go like deeply on and dive onto those principles. Let's start with the single responsibility principle, right? So what Uncle Bob mentions is that a class should have one and only one reason to change, right? So what he means about that is that a class should have a single purpose, right? So you shouldn't mix things all together, right? As an example, like the Swiss arm knife, it does too much. On software development, you shouldn't do that, right? So as I mentioned, a single purpose. And there are benefits with this approach, right? Because first, the code's readability. Your code becomes easier to understand. So anyone jumping there to maintain or simply going to understand what was created, right? Because we're focused, the code is going to be concise and simple. Another benefit, maintainability. So as I mentioned, because we're not dealing with multiple things, it becomes easier just to uh, look at the codes, provide any sort of maintenance. Stability as well, because um, the classes are going to be more specific. So you're not going to be touching uh, multiple points depending on changes that comes with requirements. The other thing, because it's specific, it's unit testable. So it helps and makes things easier for you to create like unit testing. I put basically a blog post that mentions a little bit more about the single responsibility principle. And with that, I just want to share my screen here, and we're gonna go to code onto that. Just bring this UI. So that's the blog post. So from here, you can go like to the bottom. There will be like the repository. There are links to the other principles as well. So I just clicked on the repository. If I go in here, this solid single responsibility, I'm just gonna clone that one. Let me bring my screen. All right, so that's there. Let me just open the project. I'm using Visual Studio. So let me just bring that up. Um, okay, demo. Uh, all right, I brought on to the Git. So for this one, where's Visual Studio? Okay, you open my other window here. As soon as it opens, let me just bring it back to the other screen. We're gonna see that those examples are, well, they're very popular on internet. So there are many people talking about it, right? So here, like I can see, I'm sharing the screen. Let me put like full screen on this one. So you have a way of seeing things full screen. Cool. I'm gonna show like the bad example, right? What violates the principle. So in those examples, they run, both run, but one follows the principle, the other one violates the principle. Let's go with the bad example. So in here, I just open. All right. Well, I grabbed this example, really popular, where we have this order processor. And with the order processor, what we want to do is do three things, right? Where we validate, let's say that we are grabbing an order. So you can see here, we're gonna grab this order. We're gonna do some validation. After that is validated, we save it and we notify whoever needs to listen for this operation, right? But you can see here that because we're doing the processor. In here we don't have much, right? We're only printing the screen, like just the console. But if we jump, as we implement this, it's gonna grow, right? We're gonna do validations. We're gonna embed different libraries. This is going to extend like insanely. If you're using like any sort of database or handler, this is also gonna increase, right? Not well, even like notification. Sometimes people, you're gonna do some sort of integration with another message or email, for example. But just by looking here, you can see that this is where we violate the principle because we're doing too much. So we have different responsibilities under the same wing of the order processor. If you see like what this is doing, so you're gonna see that the executable just validates, saves, and notifies. If I was to run this one, well, the result is going to be exactly the same as I run this example. right? So just doing like validation, just printing, but it validates, saves, and sends a notification. But if I go now, the principle in how we split things, you're gonna see that we have more classes, right? And that was our original class. You can see that now we have the order validator that we grabbed from the previous screen. So we have order validator dot validate. We're gonna have also, let me go back to this one, order saver, where we have the save method, and we have the order notifier that does the notify. And if you see the implementation, well, you can see that now this is very specific, right? So it's order saver does save, validator does validate, and the notifier does not notify. So this we're being like very granular, and we're putting like a single responsibility onto the implementation. That's basically what we do with the single responsibility. In the end, we're going to end up with more classes, right? More files, but we have all of those benefits because of this principle. And you can see here that, well, we have the order, then we do the validator, saver, and processor. In the end, we have like a same results, right? Like we're going to do the same as before. But as I say, this is a principle that all of us, like developers, need to follow. And that's something that you're going to use your daily basis, depending on what you're doing, right? So that's the principle number one, right? Let me just go back and bring back the presentation. All right. And let's go to the next one, the open-close principle. Um, So Robert Martin says that you should be able to extend a class behavior without modifying it. All right, so your class should be open for extension and closed for modification. All right, so that's what we have. And well, it's there are lots of benefits with that. Gonna mention that. Well, we're making like our code flexible because we are going to end up in having, well, we have the single responsibility. Now we have the open close. So if you have different requirements, what this principle allows you to do is that you're not going to modify existing code, but you're going to extend that by implementing an interface, right? So we're introducing like in here a behavior that we're going to further use for decoupling, right? So with an interface, you basically can define a behavior. And we have in here like flexibility because if you have an implementation, you want to extend it, you create another class, you implement that interface, and you just plug that onto your solution. Also, as another benefit, we have stability. We're less likely to introduce bugs uh, in our code because, well, we're not going to be modifying existing codes. So for sure, like you're going to be certain that you're not going to break things, and you're going to create new modules, new classes, right? So bugs that can happen could happen with the new implementation, but not with the previous one. And we have also, well, I also create like the other blog posts, so where you can visit later. And if I go and bring the the post, let's go to the open close principle in here. We're gonna go to the example that I put. It should be at the bottom. So we have the open close principle. Let's go in there. I'm gonna copy that. We are on this one. Let's clone that one. With that, I'm gonna close the solution. Let me open this. So it should be open close. I'm gonna bring like to the full screen as well. So you have an easier way of seeing the code. And the same as before, right? So we have like the bad example where we violate the principle, and the good example, right? Where things are done correctly. Well, we have here like the bad example is takes the previous good example from the uh, single responsibility, right? Because we start from here on the processor, right? And we have the same classes. The thing is that, right? Let's see that we're doing a saver, but we are saving onto a database. Now we want to do, well, we're using a transactional SQL, and we want to do save this order onto a NoSQL, for example. Well, assuming that this is a SQL, this is NoSQL. I'm using saying Cosmos, right? But well, we're violating the principle in here because we're introducing, uh, as I said, so we're modifying an existing implementation. For sure, we're going to be introducing bugs that could even like break whatever it's implemented in here, right? Depending on the variables that we have shared on this class. So that's where we violate the principle. What we need to do is to have, okay, be more specific, right? So we could call the previous one like DB order saver. I have only save methods, and we could create another one called Cosmos order saver and have like a single save method. And by looking at well, you can see clearly here that we have like two order savers. First, what I did, right? Let's go and see the interface. So before, right, what's the behavior that we had initially? Well, just save. So we grab that, define an interface. In that interface, establishes contracts that you know that you're only going to do the operations, right? They're expected by that interface. And when you look in here, so we just relabel, let's say, the order saver to be a SQLDB order saver, but we are implementing this interface, right? So we have that, but we no longer have the Cosmos in the same place. We have now Cosmos implemented that same interface and doing the save. All right, so with that, this is a completely new class, and well, we're not touching the previous one. So we're extending our implementation. If you look now at the order processor, so we can say that this is our order saver, the interface. Well, in here, I'm just extending the order saver. So when I create the order processor, here I have a concrete class. This is an abstraction, right? In here, we're introducing decoupling. We're going to see another principle. But you can see that, okay, I'm going to create an order processor, but I can pass any sort of order saver. Could it be a SQL? Could it be a Cosmos? Look at the program. So in here, I'm creating the validator that doesn't have like any extensions, notifier, uh, neither. But the saver here decide, okay, I want to do the Cosmos. And when I pass to the order processor, that gets run, right? So if I was to run this, well, I'm only bringing the Cosmos. That's going to be the same output from the bad codes. right? So in this case, order to Cosmos DB. If I put this one as the good, just to start, you're going to see the same, right? So you see, well, if you don't follow the implementation, the principle, you're going to end up with the same results, but your code is going to become like really difficult to maintain in the long run, right? So always follow the principle. With that, we have the principle in here explained. Let's go to the next one. Let me bring back the presentation, and let's go to Liskov substitution. Well, let me bring like the screen again. Just a minute. This one. Well, we have Liskov. So Liskov is one of those principles that we don't get to apply on a daily basis. It's it requires some level of abstraction that, in general, you're gonna do in projects or with legacy codes, but you don't get to do it on daily basis. While the single responsibility in open close, you get to see it really depending like on requirements that you have. In what Uncle Bob says, the derived classes must be substitutable for the basic classes. What it means is that, well, in here we're going to talk a little bit about inheritance and polymorphism and how they are critical for this principle to work well, right? And one of the things that we need to think about the Liskov substitution principle is that around the context, well, how your abstraction is defined. There is like a classic example where people, well, I don't know who created like this drawing, but this picture, but it says in here, if it looks like a duck, quacks like a duck, but it need batteries. So you probably have the wrong abstraction. Well, you could create like an abstraction that does more than you need, or that it does less, right? So you could like incur in having issues with the abstraction. Yeah, I'm gonna say uh, we're talking here like just saying, well, that's a well an easy example, but it needs to be easy because uh, depending on the domain, this can be really complex, right? So uh, the principle here is to the explanation here is to enable you to understand when to apply it and how to apply it, right? Oh, I mentioned that when applying this principle, inheritance and polymorphism should be carefully contextualized. Yeah, uh, I think like I'm gonna jump like to codes straight away. But if you're not aware, like more junior devs, you should be, of course, you should be um, aware and have some knowledge about like these object-oriented characteristics, right? That inheritance is when you have basically for a basic class and a derived class. So your attributes in methods, they are inherited by the derived class. In polymorphism is the ability of your objects to take different forms, right? I think like with that we can jump to code. Let me share again the article. So let's go to Liskov. So you have the article in here. You can have a look later on. But let's go to the repository. You have the Liskov in here. Let's copy that and clone it. Okay, cool. Let me close this one and bring, well, open that project, Liskov. Here we go. Let me put like in full screen. All right. So we have Liskov in here. Same old, like a bad example. right? And we have the models. When I say like that they need to be careful, be contextualized, well, I don't have, I'm just looking here the UI. Let me bring like zoom in. I had zoom in here. Zoom it. So I can just zoom that part in here for you guys. Zoom it. Uh, Hopefully that comes in. So Control 1. Yes. Right. Uh, so in here, you can see that we're going to talk about a bird. Right? And well, we have different birds in here. We have like duck, we have a kiwi, we have a penguin. Well, they, as birds, well, can we assume that they all of them eat, they lay eggs, and they fly? I put like a comment here. Can all birds fly? Well, not really, right? A kiwi can't fly. A penguin can't fly. But that's the sort of abstraction that where mistakes happen, right? And when mistakes happen like that, that you assume that your abstraction is going to enforce that behavior, you're gonna see code like that. I've seen it like in legacy codes. You can see that well we are inheriting the bird's object onto a kiwi, but kiwis don't fly. They can't fly, and you're gonna see exceptions being thrown. Classic example: exceptions or do nothing, like simply it's not applicable. Right? So that's a clear violation of the principle because abstraction wasn't applied correctly. Maybe at some stage the legacy codes was just modified by different developers and by laziness or not understanding the codes, things were just left or took like a different direction. And you're gonna see things like that, right? But if you see here like how well we're creating a penguin and creating a kiwi and polymorphism. So we're converting the derived class onto a base class. So just to say that, well, we're taking a different form of the object. So we can say, yeah, they're birds. But what happens like if I play that? Well, I think like in here we're gonna see that, well, that was a penguin. I think the penguin, well, it does nothing, right? So I don't know if they have like the, well, penguin eats, lays eggs. Can it fly? Well, it does nothing, right? So nothing gonna be triggering here. But why are the kiwi? We're gonna have like a behavior here, an exception. Well, can it fly? Boom. We're gonna see like ears. Uh, yeah, that's I think like what's worse. Well, this is bad, but this is even worse, right? Because it's simply ignoring, well, or just like avoiding the methods entirely, and that doesn't give. In general, like you see things like, okay, throw an exception and to do's like this needs to be modified, or the developers will just put like some comments to change that. But yeah, that's a clear representation of like how you violate the principle. Let's close that. Close all tabs. Let's go with the good example. All right. Um, there are two ways of how we can implement or do proper implementation with Liskov. Let's go first with modules. Case one. Well, now we can say that the birds, the bird, like the base class, only does what's uh, required, right? And we leave the specialization onto the derived class. So the bird no longer has fly. So it only does what is supposed, right? And then we leave the specialized methods onto the derived class. Let's see here, the duck. Well, inherits from birds, cool, and implements fly method. That's fine, right? So we have the base class, our derived class, and we are specializing that. And the QE itself, well, it just inherits from the birds, and that's it. That's a constructor. But that's case one. Case two, to fix that issue, that violation, we can introduce interfaces. All right, recommends that uh, because of the coupling. Right, benefits we have with interface. But let's say, so a regular bird, well, only eats and lay eggs, and a flying bird does fly. Cool. So if I come in here with birds, well, a bird is a regular bird. So I know that this is the contract, it eats, and the bird lay eggs. But I can do say that, well, a duck. The duck is a, well, sorry, let me put like it here. So I'm using like a inheritance as well. But I can say the flying bird is a regular bird and a flying bird. So it implements both interfaces. All right, so we have in here. If we come back now to the implementation, so we can say that now kiwi is a bird and duck is a flying bird. Right? So we don't have specialization onto those classes. Everything was defined through an interface. And that's it. I think like for this one, it's not something that you see that often, but it's a good heads up for you if you see code smells like those, well, I would say exceptions being raised, well, in the middle of codes where we have inheritance, right? So be careful with that. Those, I think like you can have like really difficult bugs introduced by good, bad abstractions, right? If you're looking here, like the result, case one, because we did the inheritance of duck and kiwi, and we're doing like polymorphism back to the base class as a bird. So we can say that, okay, well, the bird one that here, where birds are regular birds. So we can only say that they eat and they lay eggs, but they cannot fly. So that's why we cannot use bird one C1, which is case one in here. We're using like directly the duck. But why on kiwi, they can only eat and lay eggs, right? And on case two, where we have the interfaces, we have the same implementation of duck and the kiwi. But in here we can say that the duck is a flying bird and the kiwi is just a bird, right? A regular bird. And when we see here like bird 1, C2, so it can eat, it can lay eggs, and can fly on the same base uh, class. And while the bird, that's a regular bird, can only eat and lay eggs. So the example is there. Have a look. And let's go to the next principle. Let me go back and share again my screen. Cool. Then we have the next one, interface segregation principle. All right. So it says in here that, well, you need to make fine-grained interfaces that are client specific, right? So if interface segregation, we should have lean interfaces and not a fat interface. I can say that because in general, we need to, well, you can see that violations where we have too much being enforced by interfaces. But what we should be doing is have really fine-grained interfaces, right? One, each one serving their own purpose, right? So clients should never be forced to implement an interface that they don't use, or clients should be forced to depend on methods they don't use, right? And that's the other post that you guys can check later on. Let's go back to code and go to the article, interface segregation. And you can go to the bottom where we have the repository. Interface segregation principle. Let's clone that one. Okay, let's clone it. And let me close that. Open the interface segregation. Cool. That's loading. Nice. All right. This one, let me share full screen on my UI. Here we go. Cool. In here we have, well, you remember the single responsibility and the open-close principle. The open-close principle, we introduce an interface, right, where we are doing the order saver. We create order saver. In here, what we're going to do is that, well, we're going to violate the principle first, right? So, so remember we had like order saver. But in here, I'm creating a interface that contains too much. So it does validate, it does saving, it does notify. The problem happens when you're implementing the interface, but, well, you're forcing the client to use something or have a dependency that you don't need. And if we come to this, right? Well, what I want to do in here was to do an order validator, right? Well, I only want to do this, not that. But, well, this is the interface, so we're going to implement it. It comes down, and then that's it. You have the implementation validate, but then, well, you don't need that. We're going to throw exceptions. Well, you see that. That's the violation of the principle. And so rather than having a more, uh, well, a large interface, should break it down and be more specific, right? So with that, if we come to the interfaces, well, I want like a validator. Okay, I create an interface that does only validate. I want a saver. Cool. I just saving here. Want to notify? Yep, another interface. So they're very granular. And when it comes down to, okay, I want to do a validation. Nice. Yeah, I want to implement what's required. So I'm being very specific. I want to save it. Nice. Yeah. On the open close, you remember we created SQL DB order saver and Cosmos order saver. But that's the interface we introduced, right? And what was the other one? Notifier. So we're being very granular, and this is good. So when it comes down to the reference, well, now we can say, well, we don't need to, well, we have defined the interface, so we should use it, right? If you come to execute, you're gonna see that, yeah, I'm creating uh, the concrete object, sort of validator, saver, notifier, and passing here because I know that they uh, implement only what's required, right? If this one, I think like on the bad example I didn't show, but well, I only want to validate. So the other ones are not going to raise exceptions in here because I'm not calling them. But depending on how your code is, you could have like exceptions. Right? Same as I did the good one. For the bad one, let's go back. Well, only doing the validate order. Oh yeah, I just print that. But the other one, I print everything. And so you need to have fine-grained interfaces. That's interface segregation. Let's go back to the last but not least principle, which is the dependency inversion principle. Oops, let me share my screen here, my UI. Just a minute. Cool, I'm back. And coming to here. Uncle Bob. So he says, well, we should depend on abstractions, not on concretions. I mentioned before that, well, on constructor, we had a concretion and we had an abstraction. What's represented by the abstraction? Now you should know, right? So leveraging interfaces. That's a fun example that, well, you're not going to solder a lamp directly to the electrical wiring in a wall because, well, there is well, we're saying about the dependency inversion. We're talking about, okay, you should depend on abstractions, not concretions. But with that comes decoupling, right? Because with interfaces, well, the definition for an interface can also consider like as an abstraction because with abstractions, you know that, well, it's kind of a process of um, where you know how things should be implemented, but you don't know the details of how things are implemented, right? So the interfaces do that, bring that uh, characteristic, right, for how to leverage abstractions. One of the examples that Uncle Bob mentions or explanation is that like high-level modules should not depend on low-level modules. Both should be dependent upon abstractions. And even abstractions, they should not depend upon details. Details should depend upon abstractions. Right? So you can think in here like about, let's say, the glue, right? Because high level, let's say a function. A function has parameters. Those parameters are the glue because whatever implements on that object that's your parameter, the object itself should not depend on details, but on abstraction. So if I talk about the interface, if you pass the interface on your function, your implementation also should depend on the interface, right? There are good benefits with that, right? Resilience uh, with decoupling, right? So your changes are less likely to impact your code because if you know that you depend on a contract, you know that, well, whatever you're passing needs to implement that. That's predefined, right? So your code is not going to break. It's also reusability, so you can more easily reuse um, your modules, your classes, right? Because you know the behavior that's implemented. So if you have a different area of your code that does need to use that implementation, you can reuse it. Testability as well, unit testing. As you decouple things, they are released to unit test. That's the post that you can check later on. And let's go and dive on coding. Let me just go back and check the principle and the example. Well, that's a good one. So the example in here is basically the previous one, right? Because we don't have anything different. It's just that your order processor, I mentioned, the high level object module should not depend on details, right? So this is the glue. Our interface becomes the abstraction, right? And that's something that you're going to apply on daily basis on when coding. You should be thinking about decoupling, right? And not using concretions for that, only abstractions. That's how we define those principles. And with that, I would like to thank you for staying on this session. I don't know how long it took, but yeah, it's almost like 1 hour. I think like with that you can take as an example, and every time that you're gonna talk like about solid principles, well, take like those posts in there. They contain lots of details. The links are available, and yeah, I think like what I would like us to say is that we're gonna have a next session of the user group at the Microsoft Auckland office. So where we're going to be exploring Azure durable functions, right, in patterns, right, and how to apply them when you are creating your durable functions. And I invite you to come uh, to this in-person event. It's going to be a hybrid. So if you can only connect online, cool, does that. You can do that. And but it'll be nice to see some people faces, because in general we're only talking online and we don't get to talk directly. But yeah, I would say like thank you, and I see you next when we catch up Microsoft Auckland office. Cool. Thank you guys, and catch up next.